Another key concept that comes from working with the unit circle and working with the different triangles that are created from the unit circle is a concept called inverse trig. Now our trig functions, we've been given a measure, a degree, and we have to find what the cosine of that is, or what the sine of that is, or the tangent, or whatever it may be. The inverse trig now is going to be kind of working backwards. So the inverse trig is going to be, here's a relationship. Tell me which degree has a relationship of this value. So we have two examples here. And there's two different ways that you can talk about inverse trig. One way is what you see right here with the inverse sign, which is the -1 sign. And that just says, what this is saying is, what angle has a cosine of √3/2? And a second way to write that would be arc whatever. In this case, we're talking about arc tan of 1. So we want to know what angle has a tangent of 1. We'll start with the first one, the inverse cosine of √3/2. And that means we want to think of everything we know about cosine, everything we know about √3/2, and what triangle it is we're talking about. If we're talking about cosine, we just talked about it on the last video. Our cosine is going to be either our adjacent over our hypotenuse, because that's what cosine is, or we know it's our x value. And for us to be working with √3/2, we know that we've got to be talking about a 30, 60, 90 triangle. So √3/2 has got to be the x value. So we got √3/2. And the y value would then be 1/2. And I can fill this in now. I know across from my 1/2 is my 30 degrees. Across from my √3/2 is my 60 degrees. Right, so I'm trying to find the angle that has a cosine of √3/2. So the angle that has an adjacent side or an x side of √3/2, which one of my answers then is going to be a 30-degree angle. So if I draw this out here, this is the 30-degree angle that we're talking about. So I have this positive √3/2 for my x. Now what we'll also realize is, if I look at this 30-degree angle here, that reference angle is also going to give me a cosine of positive √3/2. So I could say, yes, this is in fact a 30-degree angle, but it is also a 330-degree angle. So I'm going to have two different possible answers here, 30 degrees or 330 degrees. Both have a reference angle of 30, both have a cosine of √3/2. Now if I look at the tangent of 1, now this one's a little bit more difficult, because when we think tangent of 1, well, when we think 1, we're thinking either a 0 degrees, 90 degrees, 180 degrees, or possibly even 270 degrees. Now, tangent is going to be y/x. So at all of those points, at 0, we're going to have x is 0, y is 1. There is no 1/1. At 90, we would have the same thing. X is 0, y is 1. There is no 1/1. Same thing here. X is -1, y is 0. There is no way to get a 1/1. And the last one is the same. There's no possible way to get a 1/1. So we've got to switch up a little bit. And remember, our tangent is our y over our x, or our opposite over adjacent. And for us to have a value of 1, we know that that opposite has to be the same as the adjacent. We only have one triangle where the opposite is the same as the adjacent, and that's our 45, 45, 90. Our sides are going to be √2/2 and √2/2, and my hypotenuse is a 1. So if I have root 2 over 2 over root 2 over 2, I'm going to see that's going to cancel out and just give me a 1. So I know this 45-degree angle where I have a positive root 2 over 2 and a positive root 2 over 2 is going to give me that positive 1. The only other place where I will have a positive 1 would be over here, because I'll have negative root 2 over 2 over negative root 2 over 2. Those negatives are going to cancel, and that'll give me my other value of 1. So inverse trig is we're trying to find the angle that has a degree of whatever relationship we see below. One more problem. Let me make this a little bit larger for us. There we go. So if I'm looking at it here, I want to look from the inside out. So this one, the first thing I want to look at is just my inverse cosine of 3 over 5. Now this is not a special triangle, but what it is my cosine. And I know cosine, the adjacent is 3, the hypotenuse is 5. To solve the rest of this triangle then, I've got to do the Pythagorean theorem. I could say 3 squared plus x squared equals 5 squared. So 9 plus x squared equals 25. X squared equals 16. X equals 4. My missing side is 4. So now I have a completed triangle. Now I can look at this. So I wanted to find, first things first, I want to find the angle that has a cosine of 3/5, which I found is theta. So this theta now is what I'm looking at here. And now what this problem says is find the tangent of that theta. Tangent of that theta would be opposite over adjacent. The answer to this is going to be 4 over 3. Boom. And it's that simple. So even when things look complicated, like this big problem we have here, take it one step at a time and use what trig you know